Now we'll talk about elasticity. We know when a force is applied on a body, it deforms or it is strained, and when the force is withdrawn, it returns to its original shape or state. A piece of rubber or a spring, let us take a spring, like this is our spring. When pulled at two ends, its length increases. When we pull this spring, it its length gets its length increases. So when we pull, the body will look like this after pulling. Okay, and returns to its original state and shape when the tension is released. So when we release this spring, it tends to go back to its original shape or state. So it is seen that due to Newton's third law, due to Newton's third law of motion, a restoring force or reaction force is developed in the body when a force is applied on the body. So there is actually happen a restoring force. Storing force. Okay, when we pull or when we apply an external force, then there will be a restoring force created. So this restoring force or reaction force is developed when an external force is applied on the body. When the force is withdrawn, the restoring force or reaction force helps the body to return its original state. So when we withdraw the external force or this pull force, then for due to this restoring force or reaction force, it tends to go to its original shape or state for this spring, for the purpose of this spring. The amount of strain or deformation of a material depends on the magnitude, point of application of the applied force, and also the property of materials. There are 3 points. First point is point of magnitude. So first point is depends on the magnitude. That means how much force is applied. Point of application of the applied force. Point of application of the applied force, that means at which point we apply the force. And the third point is, or the third factor is materials. The body is constructed with which materials. For due to for these three what should I say, for these three component, or the for these three factor, the elasticity or the restoring force is acting according to these three factor. The property of the body is called elasticity. So this property of the body is called elasticity. So what is the definition of elasticity? The definition of elasticity says that the ability of a body, this is a body, to regain its original shape and size. So when we release the pull force, it tends to gain its original shape or size. When the deforming force is withdrawn, when the pull force is withdrawn, is called elasticity. Is called elasticity. So it says that when we withdraw our external force, the body regain its original shape and size, and this property is known as elasticity. So you have to remember this definition of elasticity. Now coming to the next part, some quantities relating to elasticity. We have to know some quantities or some terms about elasticity. So first term is perfectly elastic body. So what is perfectly elastic body? It says that if a body recovers its original shape and size as soon as the deforming force is withdrawn, the body is called perfectly elastic body. So when we withdraw the force, it recovers its original shape and size. So if that happens, then we say this body is known as perfectly elastic body. What is perfectly plastic body? if a body retains its changed shape and size, and after the removal of the deforming force, then that body is called plastic. That means when we apply force on a body and the body does not retain its original shape and size, perhaps it retains, or it actually seen as the changed shape and size when we apply the force, then this kind of body is known as plastic body. Number three, perfectly rigid body. So a body is called perfectly rigid body if it does not suffer any strain under the action of deforming force. That means when we apply force, it doesn't have any strain. So this kind of body is known as perfectly rigid body. And what is elastic limit? This is an important point. This is an important point. So it says that it is the maximum value of the applied force up to which the body remains perfectly elastic, and when the limit is exceeded, the material of the body shows plastic behavior. That means there is a limit for elasticity. When we go beyond this limit, then the body does not show any elasticity properties, perhaps it shows some plastic behavior. This limit is known as elastic limit. Okay, suppose we use a rubber. After some time the rubber, we pull the rubber and the rubber retains its original shape. Again we pull the rubber, the rubber retain its original shape. But after a limit, after some, when we pull the rubber after a limit, the rubber doesn't retain its original shape. Perhaps it gets break, or it gets changed shape. This limit is known as elastic limit. Okay, then coming to the next point, which is known as breaking weight. What is breaking weight? The minimum applied force or load for which a substance either breaks or snaps is called breaking weight or load. That means when we apply some force or load on a body or on a substance, so for this force or load, the body gets break or snaps. So this loads is known as breaking weights or breaking load or breaking force. So this is the force, minimum force for which a substance get breaks or snaps. Now what is breaking stress? The breaking stress says that the force per unit of a body for which the body breaks is called breaking stress. Suppose this is a material which has length L, and we applied some force or a load here. So we applied some load here, and for which this body gets break. This body gets break or snap. So when this weight is applied, it feel some stress. What is this stress? Per unit of a body for which the body breaks. So force field per unit. Force field, the force per unit of a body. So we can say that breaking stress is actually equals to breaking weight for which the material goes break divided by area of the body. Okay, so we can say that this is our breaking force or breaking load, and this is the area. So area of this, what should I say, of this, the cross sectional area of this of this pipe or of this material. So this is the main concept of breaking stress. So now we have to know two more terms, which is known as strain and stress. So what is strain? Strain says that the change production in the dimension of a body under a system of force or couple in equilibrium is called strain. Suppose this is a rod of length L, and when we apply some force, or suppose we add some weight there, it actually gain, or it actually stress. Okay, which actually increases, the length is increases. Suppose this increasing length is del of L. So strain says that the change produced in the dimension of a body. So the length dimension is changed due to this force. Length dimension is changed due to this force of a body under a system. For this system, this weighted system or couples in equilibrium is called strain. So for strain, we write the equation as strain equals to changed changed dimension, or uh, the length increases or the dimension changed. So suppose this is length of L, and after del L del L increases, the length, the changed length is L prime. So we can write this strain equals to L prime minus L divided by original length L, or you can write this thing as del of L by L. This is the formula of strain. Now coming to the next part, stress. So stress says that stress is the force per unit area of an object. So when we applied some force here, or when we applied some load here, this cross sectional area of this rod or of this pipe will has some stress, and this stress is actually equals to force divided by area. Okay, this is actually, this stress and breaking stress are actually, and here for breaking stress, this force is actually the breaking force. Sorry, that will be force, breaking force.